Well, you might be asking yourself, where is Miss Cowan? Where is this voice coming from? Is this the ghost of Miss Cowan? No, I'm having webcam issues. It makes me look psychedelically glowing purple, so you'll have to do without my bright and shining face for this lesson. We're going to be doing our last lesson on Algebra 2 review, and we're going to be talking about the Cartesian plane, what absolute value is, distance formulas, midpoint formulas, equations of circles, and some applications. These provide the foundation for the material that's going to be covered in pre-calculus. Yes, we're getting closer to doing actual pre-calculus. If you know about absolute value, the definition is the distance a number is from 0 on a number line. So if A is positive, the absolute value of A is just that number. So absolute value of 3 is 3. If A is a negative number, for example, negative 3, absolute value of negative 3 is positive 3. You take the opposite of it. And if it's 0, it's 0. So here's some properties of absolute values. One thing that I find interesting is that you can break apart the multiplication and you can break apart the division. If you have a division problem, you can separate the absolute values in the quotient there. Absolute value of a negative number and its opposite are the same. Let's talk about the Cartesian coordinate system. We have the midpoint formula, the distance formula. So if we talk about 2 points, I'll say this is point P, x1, y1, x coordinate, y coordinate, and we've got point Q, x2, y2, that's the second x coordinate, second y coordinate. Then the midpoint formula is going to give us the coordinates of the point that's exactly halfway between P and Q. So the midpoint is going to be the average of your x's, comma, the average of your y's. So this would be your x coordinate of the midpoint. This would be your y coordinate of the midpoint. Don't forget that when you're finding the midpoint, you're going to have coordinates. The distance formula also uses the coordinates of the point to find how far it is from P to Q. And you could also base it on the Pythagorean theorem. If PQ is the hypotenuse of a right triangle, this is where the distance formula comes from. So PQ is the difference of my x's squared plus the difference of my y's squared. Notice when you're finding distance between 2 points, you do not put a segment on there. If you see 2 capital letters like this with no segment bar, that means the distance from P to Q. Let's see how these formulas work now. The actual coordinates of point P are 1, negative 1, and Q is 3, 1. So if we want to find the midpoint of the segment connecting P and Q, we're going to take the average of our x's, which is 1 plus 3 divided by 2, and then the y coordinate of our midpoint would be negative 1 plus 1 divided by 2, and that's going to give us 2, 1/2. So that's where the point would be. And we look, if we go over 2 and up 1/2, we can see that's going to be dead center from in the middle of the segment joining P and Q. If we want to, there's also distance on a number line. So if they just give you 2 numbers and they're not in ordered pairs, this is how it's defined. The distance between 2 numbers is the absolute value of their difference. And absolute value of A minus B is the same as the absolute value of B minus A. Find the midpoint of the line segment with the given endpoint. So let's say we have negative 1, 3 and 5, 9. We're just going to plug into the formula. Here's our midpoint formula. Averages of our x's over 2 and averages of our y's over 2. Negative 1 plus 5 divided by 2, 3 plus 9 divided by 2. This would be my x, this would be my y, so I'll end up with 4 over 2, 12 over 2, which is 2, 6. And that would be our midpoint. We signify that with a capital M. If we're asked to find the distance between 2 points, the first thing we need to know, are they ordered pairs or are they on a number line? When I look at this first problem, this is on a number line because there's no parentheses. These are 2 that are on in the plane, so I'm going to use the distance formula. This one, since these are on a number line, I'll just do the absolute value of their difference. So the absolute value of negative 9.3 minus 10.6 is going to be negative 19.9. Could I have gone the other way? Absolutely. You'll end up with the same answer. So we'll end up with 19.9, whether we do negative 9.3 minus 10.6 or 10.6 minus negative 9.3. These 2 are on the coordinate plane, the Cartesian plane, so we're going to have to use our distance formula, which is difference of our x's squared plus the difference of our y squared. So I'm going to have 1 minus negative 4 squared plus 1 minus 3 squared, which ends up with 5 squared plus negative 2 squared, 25 plus 4, which gives me the square root of 29. Rewrite the expressions without the absolute value symbols. They want the exact value, and what you have to be aware of is you want to make sure that it's positive. So if I wanted to find the absolute value of 3 minus 8, I know that's negative 5, the absolute value of negative 5, which is positive 5. The way I can be assured a positive result is if I list the bigger number first. So when I'm doing these, to ensure the positive result, check to see which number is larger. Is it square root of 7 or 5 over 2? Put that number first in the expression, subtract the smaller from the larger. Since the square root of 7 is larger, we're going to put it first. So it's going to be the square root of 7 minus 5 over 2. That's all you have to do for that one. Let's try to find the area and perimeter of the figure. The biggest thing is we need to sketch that graph. That's a big hint. If you sketch it, sometimes you get lucky and get a square, and so it's very easy to figure. So negative 2, 1, negative 2, 6, 4, 6, and 4, 1. If we plot those points, there's where they would be on our coordinate graph. When we connect them, we'll say this is A. We're going to label them just to keep things straight. When we connect them, we get a square. Or a rectangle, it's probably a rectangle. And we can actually just count how long the sides are, 1, 2, 3, 4, 5 from A to B. And if we can't, if we get like a parallelogram or something, we may need to use the distance formula. But in this case, we got a nice clean rectangle. So we've got a 5 there and a 6 there when we go from B to C, 1, 2, 3, 4, 5, 6. Same on the opposite sides. So perimeter, remember if a security guard is walking the perimeter, he's going around the outside of the figure, so you're adding. So the perimeter is twice the length plus twice the width, so we're going to have 10 plus 12, which is 22. The area of a rectangle is length times width, 5 times 6, and this is how many squares cover that space. So it's two-dimensional space. So we'd have 6 times 5, and we have to say 30 square units. Area and perimeter are very different measurements. This covers the two-dimensional space. It's kind of like when you think of a lawn and you've got the grass. The grass covers the area. The fence is the perimeter around your yard. All right. For homework, you're going to have one that has the area of a parallelogram, and you have to remember that formula is 1/2 base times height. So you're going to have to find the height of that parallelogram. And you can do that using the distance formula, and you should be okay. Find the perimeter determined by these points. Sketch the graph first. I like to label my points. I'm going to label them P, Q, and R. So negative 5, 3, 0, 1, and 4, 4 would go right there on the grid. When we connect them, we have 3 sides. We have a triangle. Now to find the perimeter, we need to know how long the length of PQ is. So we're going to have to use the distance formula. So we're going to plug the points for P and Q into the distance formula. So negative 5 minus 0 squared and 3 minus 1 squared, then we're going to add those together. We'll get the square root of 29. Then we're going to need to know the distance from P to R, which is going to be 4 minus 0, well, I guess I'm doing R cubed, plus 4 minus 1 squared. We're going to take the square root of that, and we'll get that length of the segment QR. So we're going to have square root of 16 plus 9, which happens to be square root of 25, which is 5. And lastly, we will do the distance from P to R, which is going to be 4 minus negative 5. So we did 4 minus the negative 5 and 4 minus 3. Square both of those, you're going to end up with square root of 81 plus 1, which is square root of 82. Now this is going to look pretty ugly because you've got some square roots and some whole numbers, but the perimeter is going to be square root of 29 plus square root of 82 plus 5. That's going to be approximately 19.44. The last example on this one is you're going to draw a scatter plot of the data. And the big thing on this is labeling your graph. Since these are in years 2001 to 2007, it goes along their x-axis. So we're going to have 2001, I'm going to skip one, 2003, 2005, 2007. And then these go by thousands. Instead of starting at 0, however, I'm going to start at 57,000. So this first line's 57,000. Then each line is 2,000 more. So 61,000, 65,000, 69,000, and 73. When you draw the scatter plot, all you do is estimate where these points would be. So I go 2001, it's approximately at 57,000, so I'll put a point there. 2002 is approximately at 59, so I'll put a point there. And 2003 is 61, so I'll put a point up there. 2005, 67, so I'll put a point there. And 2006, 70, and you just continue on until you've completed your scatter plot. You look at the scatter plot to see what kind of a relationship that would have, and you can see that's pretty much either a linear or a quadratic relationship between the data. We're going to finish your notes tomorrow where we'll talk a little bit about circles. Talk to you then. Bye.